Lecture, I will talk about the standard C library and focus on the most important header files. There are 24 header files in C99 and 29 in C11. New ones are, for instance, about parallel programming. And I will not talk about that in this course, and not every function, of course, either, since the largest part of the C standard is the library, and that's quite a lot. But let's start with assert. It is a macro, and it can be used to check if our assumptions about the state of the program are actually true at runtime. For instance, here we assume that the star list is not a null pointer, and if it is, then the program will terminate. It will print a message such as assertion failed on line that, in function that, in file that. And this can be very useful during development, and sometimes it's also used in production code. If we want to disable this check, we can define this macro when we compile the source code. And then the effect of this is just nothing, and that means we should not do anything important as the argument to assert. For instance, this is a really bad idea, since if we disable this, the file will not be opened. And it's not so good. And how to implement assert? Well, that can be seen. It's similar in this example, and it was explained in the lecture about the C preprocessor for the macro fatal, which does something very similar. Okay, and if this assertion fails, then the program will have something called an abnormal termination. And a program can have a normal or abnormal termination. It's normal termination if it terminates by returning from main or calling exit, and that's the same thing actually, as I have mentioned. And it's abnormal termination if it crashes, then it gets a signal, and it is terminated from this. And this will call the function abort, which will generate the signal sigabort, which will terminate the program. Okay, so define this if you don't want to pay the execution time for these tests. Of course, such tests can be quite harmless and not cost very much, but there can of course be calls to functions which do consistency tests, which can take a lot of time. Okay, so if we want to test this during compilation instead, can we do that? This is not the working approach, and the error with this is that we assume that the preprocessor knows about the size of a pointer. It doesn't know about anything except macros and simple arithmetic. So this doesn't work. In C11, it was introduced a new keyword called static assert that can be used to achieve this. Okay, and the compiler will see that something doesn't hold, and the compilation will fail. But if we don't have a C11 compiler, we can do this manually, so to speak. And the idea is to get a compiler error if our assumption fails. And a simple way to do that is to declare an array which has one element if our assumption is true and minus one element if it's false. And we are not allowed to declare an array with 0 or a negative number of elements. So therefore the compiler is required to complain. Okay, sometimes it's an extension in the GNU compiler to have an array of 0 elements, but that's a different story. But to make sure to get an error, use a negative number of elements. So how does this work? Well, this expression is evaluated at compile time, and then I should say the compiler is forced to evaluate this at compile time. Okay, and if it's true, then it will just work fine, and if it's not, then it will end up with an error. What is wrong with this, or not wrong but bad, is that we will have an array that is not used for anything. So it's a waste to generate an array, to create an array for this. And what we can do instead is to introduce a type def, so that the only thing that happens is that we create a new type if it works and complain if it doesn't. Okay, now we have the problem of having to invent a new type name for every time we want to do something like this. And that's a very problematic issue, to invent new names. Well, it's not very, but it's annoying if we can do it automatically. So what we can do is to concatenate this array identifier with the line number using this token concatenation operator. And then we can have one on each line if we wish, but not two on the same line. And how to do that, the details is explained in this example in the book, but I will not ask about in the oral exam for you to give the details, but the principles are good to know. Okay, and when I mean that, it is the trick to make an array of a negative number of elements to get the compilation error, but you don't have to bother about learning exactly how this token concatenation is involved in this. Okay, I have once had it as the last question to an exam in the C course, and it was not very many who could answer it properly.